Well, good evening, everybody, and welcome to the Sustainable Shine Dome Possible Futures Symposium. I'm Tracey Ireland, the Director of the Centre for Creative and Cultural Research at the University of Canberra. I'd like to first acknowledge the Ngunnawal people, who are the traditional custodians of the land on which we're meeting today, and pay respect to the elders of the Ngunnawal Nation, past and present. I extend this respect to all Aboriginal and Torres Strait Islander people in attendance with us today, and to all First Nations people and traditional owners on whose lands you gather as we come together for this online symposium. I'm delighted to be speaking to you this evening from the beautiful Shine Dome in Canberra, home of science in Australia for 7 decades. The Shine Dome's elegant, classical facade epitomises Canberra's mid-century modern heart, redolent of the optimism and aspirations of the post-war period in Australia, and of the envisioned role of science in securing and guiding our nation's future. And perhaps never before in my lifetime has this mission seemed so urgent. The Sustainable Shine Dome project has developed and evolved through what we can only now think of as very interesting times. Of course, I'm referring to the massively damaging hailstorm that in early 2020 did so much damage to the Shine Dome and surrounding parts of Canberra, preceded by the Black Summer bushfires of 2019-2020, and closely followed, of course, by the pandemic that has shaped the form of tonight's event, but which has also shaped the urgency and evolution of our project in more profound ways. Those of us here in Canberra were so delighted to witness the amazing work done on the dome throughout last year as artisans handcrafted the new copper cladding to replace the hail-damaged original roof, which then gleamed cheerfully for a few months and has now softened into its landscape setting. But for those of us on this project, the pressing reality of our sustainability objectives has never been so starkly present. I want to congratulate and thank everyone from the Australian Academy of Science who has partnered with the university on this project. In particular, Anna Maria Arabia, Hans Bachor, Paul Richards, Lisa Crocker, Tom Carruthers and Katie Little. From the University of Canberra, I want to acknowledge the great work of my colleagues, my co-chief investigator on this project, Professor Michael Jasper, and our research associate, Hakim Abdul Rahim. From GML Heritage, I want to thank Rachel Jackson and Catherine Forbes, who is one of our speakers this evening. And from GHD, Ty Hollingsby, Ian Dixon, Jensen Seor, Ari Hammerschlag, and May Ngui, who is also speaking from the Shine Dome this evening. I also want to welcome and thank our distinguished guest speakers, Professor Peter Doherty, Ross Harding, and of course, Professor John Shine, the Academy President. Like you, I can't wait to hear their contributions this evening. So the Sustainable Shine Dome project has been funded by the Australian Government through the Australian Heritage Grants Program from 2019. And this partnership project aims to develop a sustainability plan as a pathway towards the future viability for this national heritage listed building. Our multidisciplinary team has been investigating innovative approaches to identify progressive energy and emissions reductions, as well as a range of sustainability measures that will contribute to the ongoing protection and promotion of the Shine Dome's unique national heritage values. So as a part of the project, we've had a series of public symposia that have built a really exciting dialogue around heritage values and sustainability. So we've had two so far, the first in December 2020, and that was entitled Envisioning Sustainable Futures for Heritage, which set the groundwork for the project and its research questions. We had a second event back in March 2021 entitled Planning Sustainable Futures for Heritage, which focused on more technical discussions relating to carbon emission reductions and on creative approaches to cultural heritage sustainability. And these events can still be viewed online, and I recommend them to you. So this evening is our final public symposium for this project, and it's entitled Possible Futures. And so we'll focus this evening on the broad challenges and practical issues in the Australian response to climate change, lessons for a carbon active future, and specific findings and recommendations for the Shine Dome itself. Of course, there are many possible futures, and this event provides an opportunity for you all to participate in a conversation around the potential pathways that lie ahead of us. So at any point in the event this evening, you can send questions and comments to the speakers, and I urge you to do so. You can click on the link on your screen or use the QR code to send those through. And please also join in the conversation on Twitter using the hashtag #SustainableDome. So I would now like to welcome Professor Nanda Dasgupta, Fellow of the Australian Academy of Science, to speak on behalf of the Academy. And Nanda will be followed immediately by Professor Jason Bainbridge, Executive Dean of the Faculty of Arts and Design at the University of Canberra. Thank you, Nanda.
Thank you, Tracey. I too pay my respects to the Ngunnawal elders, the traditional owners of the land on which the Shine Dome is built. I also acknowledge and pay respect to the traditional owners of all the lands on which the Academy and their fellows operate, live and work. These lands hold the memories, traditions, cultures, and hopes of Aboriginal and Torres Strait Islander peoples of Australia. Sustainable practices are core tenets of Australia's Indigenous cultures, and we have a lot to learn from Indigenous practices on how to work with the environment. I'm Professor Mahananda Dasgupta, a Fellow of the Australian Academy of Science, and I'm delighted to be here at the newly restored Shine Dome. I'm disappointed we could not welcome you in person to the Shine Dome for this special event due to difficulties associated with travel restrictions for the speakers. The Shine Dome is, however, open for business, and we look forward to hosting guests from outside ACT soon. As Tracey mentioned, this is the third and final event for the Sustainable Shine Dome Research Project, a project focused on developing an innovative sustainability plan for this heritage-listed building. This dome is a unique structure with a solid concrete shell and at over 45 meters in diameter, one of the biggest of its kind. It was designed by Sir Roy Grounds as a meeting place and built in the 1950s, a time of great economic and intellectual recovery, a time of optimism. Australian University had just started to train PhD students, and nearby, the ANU had been created to build national research capacity. Science opened a path to the future, as indeed it is doing even today in facing the current challenges. The Australian Academy of Science is the owner and custodian of this building and continues to provide independent scientific advice, promote international engagement, and build public awareness of science. The Shine Dome, so well loved and well known in Canberra, is a premier example of architectural heritage. The building houses considerable cultural heritage, records that document the progress of science and the lives of scientists. The building has served its function with distinction, a place for scientific discourse, for the exchange of latest scientific information and vision for the future. In early 2020, the roof of the dome suffered damage from extreme hailstorm and had to be repaired. In addition, unrelated to the storm, the heating technology had to be upgraded. Both these upgrades provided an opportunity to include the newest technology and take into consideration sustainability. Sustainability in its many forms is a key challenge for this century. The question arises, how to make this remarkable building sustainable, to continue its role for generations and even become an example for maintaining a thriving activity based on cultural heritage. This intellectual challenge was taken up by a highly experienced and enthusiastic team of experts from a diverse group of project partners, University of Canberra, GML Heritage, and GHD Engineering. The project has given so much energy to this project, and thank you all for joining us this evening to learn about this project, the project report as it nears completion, and the ways to make this remarkable building sustainable into the future. To hear how changes can have a positive impact for our iconic building, all of us. Now, I would like to hand over to Professor Jason Bainbridge, Executive Dean of Faculty of Arts and Design at the University of Canberra. Thank you.
Hi everyone. I'm delighted to join Professors Nanda Dasgupta and Tracey Ireland in welcoming everyone, the online audience and those here at the beautiful Shine Dome on this crisp winter evening, to this final symposium of the Sustainable Shine Dome project. Before we begin the proceedings, I would like to acknowledge and pay respect to the traditional owners of the land on which we meet, the Ngunnawal peoples. It is upon their ancestral lands that the University of Canberra is built, as well as the Shine Dome where we are today. As we share our own knowledge, teaching, learning, and research practices within this place, may we also pay respect to the knowledge and traditions of the Ngunnawal peoples. As Tracey has noted, this evening's symposium is titled Possible Futures. The event is part of a larger research project focused on securing the long-term preservation and promotion of the unique national heritage values of this beloved national icon for generations to come. As with the first two symposia in this series, this evening is intended to provide an opportunity for a public conversation around the complex and ever more intertwined facets, the cultural, the economic, the environmental and the social of sustainability and their relation to heritage matters. This opportunity for the University of Canberra to partner with the Australian Academy of Science, as well as industry leaders GML Heritage and GHD Engineering, to develop an innovative sustainability plan for the National Heritage-listed Shine Dome is exactly the type of applied, mission-oriented research in which the University of Canberra excels, and where we pride ourselves on working together with our partners to solve the pressing problems that we face as a community and as a nation. The Centre for Creative and Cultural Research in the Faculty of Arts and Design, where the lead investigators for this project are based, hosts a diverse portfolio of inter- and multidisciplinary research projects that combine humanities and creative approaches with the sciences, engineering and health disciplines to develop innovative responses, to improve well-being and to produce social and cultural outcomes of importance to us as a society. Other examples of these approaches are found in our current ARC linkage research project in partnership with the ANU, developing laser technology to ensure the future conservation of that other well-known heritage-listed icon, the Sydney Harbour Bridge. And some of you may have also been aware of the Hague Park experiments undertaken last year here in Canberra, and which just won a Planning Institute of Australia Award for excellence in public engagement and community planning for its work in using art and play to transform a previously perceived unsafe space into a treasured and fun community asset. Finally, I'm delighted to announce the recent award of a new Australian National Heritage Grant to be launched later this year, using digital modelling to manage climate change impacts for the old Great North Road World Heritage Place in Darug National Park, north of Sydney. This kind of innovative research has contributed to UC's recent rapid rise in world rankings and to our position as one of the top 10 universities in Australia in the Times Higher Education Young University rankings. But what is clearly more important to us than rankings is this kind of research that contributes to the public good and makes a positive contribution to our community. So I wish you well for this evening's symposium, and particularly would also extend my thanks to Professor Doherty and Ross Harding of Finding Infinity for generously joining us today to share their experience with the team and with this audience. I also thank Catherine Forbes from GML Heritage and Ngui, GHD, and their colleagues for the work over the course of the project and this evening's presentations. And most especially to Professor John Shine, President of the Australian Academy of Science, for his participation throughout. I look forward to each of their contributions, not only for what it reveals today, but perhaps more importantly, for what it sparks: ideas, revaluations, further research, and future implementation of works and activities to preserve and promote the national heritage values of the Shine Dome. Have a great symposium.
Well, thank you so much, Nanda and Jason, for your kind words to start us off this evening. And now I'm very honoured and delighted to commence the symposium with a conversation between Nobel laureate and Academy Fellow, Professor Peter Doherty, with our colleague Emeritus Professor Hans Bachor, our co-investigator on the Sustainable Shine Dome project. They're exploring the urgency surrounding Australia's response to the climate change crisis and the role of the Shine Dome in maintaining a national conversation around these and other matters.
Professor Peter Doherty became a Fellow of the Academy nearly 40 years ago. An immunologist by scientific discipline and a Nobel laureate, Peter has been active in responding to the COVID-19 pandemic and been outspoken about the need to take action on climate at the same time. Welcome, Peter.
Pleasure to be here, Hans.
You have had a very eventful year and a half since the COVID-19 pandemic began. What has been your experience and how have you been part of the response?
Yes, I thought I was retiring at age 79 at the end of 2019, and then suddenly COVID hit us, and it's right in my area of expertise that I've been working on for 50 years. So I quickly joined our team at the Doherty Institute, and my role has actually been to serve as a discussant. I'm the patron of the Institute, which means basically I do what the director tells me to do when she tells me to do it. But I basically acted as a discussant on our 2 to 3 times a week meetings, and I've been doing communication, public communication, talking a lot on broadcast media to journalists, and also writing a weekly column for our website that's called Setting It Straight.
Yeah, it's been fantastic, Peter, to help us with the public communication. Now, in December last year, you spoke about the link between climate change and future pandemics. How are they connected?
The link between climate change and future pandemics is like the link between climate change and a lot of things. It's kind of indirect. There are many aspects to it. As we have issues with, for instance, food production in particularly developing countries with climate change, that means people turn more to wild animals as a source of food. There are those cultural traditions anyway. It means people are moving more into forested areas and into areas where you can be at greater risk of contacting wild animals, which will carry novel pathogens. And of course, with COVID, we're talking particularly about bats. So there are just so many elements to it. With infectious disease, obviously water quality is an enormously important factor, not so much a factor in pandemics, but a factor in having clean water locally, where we get ocean flooding or flooding, and we overwhelm sewage systems, where we lack water and water becomes contaminated. There are so many levels to it. But basically, it puts more pressure on all ecological systems, and we're part of those ecological systems.
Now, like the pandemic, like COVID-19, climate change is a global issue, and that requires an evidence-informed response. You were among the 100 Nobel laureates who signed an open letter to the world leaders calling for action. Why are you so passionate about it?
But quite frankly, it's in your realm of physics rather than mine of biology, Hans. So you're more familiar with the actual science than I am. I've talked a lot with climate scientists since about 2002. I've served on various committees, chaired committees, and gone to lectures and so forth to try and inform myself about the causes of climate change. But when it comes to climate change from the point of view of biologists, what we're interested in more is in the effect on biological systems, including us. And we're interdependent. I mean, for instance, the bees do pollination, so do bats and birds. So all biology is interdependent and interactive. And the problem with climate change is that it's an inexorable progression. It's cumulative. And that the more greenhouse gas we put into the atmosphere, the more trouble we're in. We understand that very clearly, but it seems difficult for people to grasp the full implications of that. Now, I think of it, one way I try to explain it is like lead poisoning, a cumulative, progressive toxicity. And the thing with this, unlike COVID, I mean, COVID at its very worst, or a pandemic, can kill enormous numbers of human beings. It's not killing enormous numbers, but a pandemic could do that. But climate change is killing off species across the spectrum, including species which we're dependent on. We're very dependent, for instance, on the kelp forests in the ocean, the plankton and the trees for converting carbon dioxide back into oxygen. We're totally dependent on ecological balance and ecosystems. I think climate change is the greatest threat that humanity has faced in the modern era, going back to the beginning of science and before that.
Now, we're all part of that. And looking now at Australia, you have been a fellow of the Australian Academy of Science for about 40 years now?
Yes.
What does the Academy represent? What can it achieve?
Well, the Academy is our peak scientific body, and together with the Academy of Technological Sciences, we kind of speak together for the science and science-based industry. And the two academies talk to each other all the time, of course. We also have roles in representing Australian science on various international committees and in various international formats. So it does that. It's now having a somewhat greater role than it's had in the past on helping to advise government. It has been a bit marginalised. There's been issues on both sides there, but it's now doing a lot better with that, I think, and I think everyone benefits from that. it has a lot of expertise it can draw on. The members of the Academy are our top scientists a bit in the older side, because they're elected on the basis of merit and reputation. And so, but you get the leading scientific themes in the country represented on the Academy. So it's a tremendous resource to draw on. The Academy also does great things in science education and promoting science in schools and so forth that really are important to the country. Too many Australians are unaware of it, and I wish many more were. It's the equivalent of the National Academy of Sciences in the United States, which is immensely powerful. The Royal Society in London, again, the oldest scientific academy in the world, and so on. So it's a very important institution for Australia.
Well, thank you, Peter, for challenging us to do even better. Now, today, the event is about heritage, this magnificent building. It's about sustainability, and that leads us to climate change and global challenges. So could you give us some examples where you think in the area of sustainability, climate change and pandemics, what we could do as an academy?
The Australian Academy of Science, I've heard this from leaders of the big academies, namely the Royal Society and the National Academy of Science. If you take the academies of science in the English-speaking world, the Australian Academy, from our rather small country and population sense, is regarded as number 3 in putting out great scientific information. We're very good at that. We've done it for a long time. And if you want to know about climate change or about COVID, you can go on to Australian Academy of Science websites, and you can read the local synthesis from across the spectrum, both from the fellows themselves who are represented in these areas and are leading figures, and from others they consult with. And so it's a great source of good information, and it's linked to the other Australian Academies of Science. So it's that. It's also an aesthetic wonder in our capital city of Canberra. Many people will have seen the Academy of Science. It's kind of a flat igloo-shaped thing, not that one on Parliament Hill, but another one with a bright copper covering over it. And that's the Australian Academy of Science. It's a very fine heritage building and something that all Australians can relate to, I hope.
So, having been a member for such a long time, would you like to share some memories from your visit to the Shine Dome from the past?
Well, of course, the Academy is part of life for senior scientists in Australia. I've spent less time there than I might, because I've spent a lot of those years I was outside the country. So I wasn't going to the Academy regularly. When the Nobel Prize happened, I was living in the United States. That was in 1996, but I just happened to be back in Australia for the wedding of our eldest son and daughter-in-law. So there were events hosted at Parliament House by John Howard to celebrate the Nobel Prize, and also at the Academy. I think we had a bus running around. So I remember that fondly. But I've known the senior people in the Academy for a very long time, including many of the presidents. They've done a wonderful job, and they've gradually, I think, been making the Academy more connected and more relevant to the Australian people.
So we had a very busy year here at the Shine Dome. As you recall, in 2020, it was hit by an extreme weather event. The hail damaged the roof above here. It broke many of the skylights. The exterior of the room has now been repaired, and there's more work to be done on the inside to keep it alive as the home of science. So we had a strong local response to the local pandemic. And if I draw the analogy, what is the link between the local action, like we had to deal with climate change locally with the hailstorm, and the global challenges?
Well, you know, the great aphorism that was, I think, first stated by microbiologist René Dubos in the United States, who has actually partly trained Frank Fenner, who was a great Australian identity and a great identity at the Academy, who was both a microbiologist working on infectious disease, but also founded what became the Fenner School of the Environment. So he had much the same concerns as I do in infectious disease and pandemics and so forth. On one hand, he was very involved in the myxomatosis eradication program and in the environment on the other. And he got that from his mentor, Sir Macfarlane Burnet, another Nobel Prize winner who was one of the founding members of the Academy when it separated from London's Royal Society. So the aphorism is basically think globally, act locally. So we've seen how that works in Australia with COVID. We've been acting locally. In many cases, it's been at the level of state governments, which has been very interesting. We've all learnt a lot about how Australia actually works and where it doesn't work too well from the COVID-19 crisis. And we can see how different state governments have done different experiments with trying to keep this virus under control. Some experiments have worked better than others. So it's local action is everything. What we do ourselves, how we act, what we do with respect to things like fossil fuel consumption, cars we drive and how we drive them and all those sorts of things. So global action, global perception is totally important. And that's something that's up to our government really to do those interactions. And it's also up to our government to try and get that local response properly tuned through proper policy settings. But each and every one of us as a human being needs to do what we can, both on the COVID front and on the climate change front.
Now, we have responded locally here with the modernization of the Shine Dome. For example, we have gone to a new heating system, which is electric and with renewable energy, is actually as much zero emission as you can imagine. So our project here at the Shine Dome, which we are discussing today, is to go towards zero net emission for the Shine Dome. And we are drawing on expertise in architecture, heritage, engineering, and science. From your perspective, why are collaborations like this so essential to meet the global challenge of climate change?
I lived in Scotland for 5 years, and they have a saying in Scotland, which is every mickle makes a muckle. A mickle is a very small thing and a muckle is a very big thing. And so the Academy can do more than a mickle because it's an influential organisation with an intellectually powerful membership that's disseminated through Australia. So what the Academy does is very important. What Canberra does is very important. Canberra has done an extraordinary job of transforming its energy supply and generation sector. It's really done a great job. The state government, we look to that in that respect, is, say, South Australia, which has done a terrific job. So we need to take those examples and we need to take them down to the level of us, and we need to impose them where necessary on government. And the way we do that is we vote, and we must all vote. And so I've been advocating that every Australian of voting age needs to be registered to vote. And some young people think that it's hopeless voting. That's not true. There are alternatives. And we all need to look at every candidate, every political party, and assess whoever we're voting for is acting on climate change. And we need to cast our vote accordingly. If it doesn't, no matter what we say about how important we think climate change is, if we don't get the political equation right, the country will never go in the right direction.
Peter, that's very sound advice to our audience and to everybody in the country. Now, we have learned during the pandemic that it was important to change our personal lifestyle, our attitudes. Do you think the same applies to climate change, that we personally should change?
Well, we read in the newspapers when people do polls that the majority of Australians want action on climate change. But if we have to want action enough to make that obvious to the politicians, and we're not making it sufficiently obvious to some politicians, it seems. So we need to do that. We need to use our person power, people power. This is a democracy. We have an enormous advantage in living in an open, free democracy. And we have to make that democracy work. Democracy doesn't work if people are not engaged, if they do not inform themselves and they do not act and vote accordingly. We have to do this ourselves. It's down to us. It's always down to personal responsibility in the end. And that's as true of COVID as it is of climate change. And we know with COVID how that works. And we know how important it is. For instance, in this latest flare up in Sydney, which currently looks pretty dangerous, we know how important it is for everyone to act responsibly.
Thank you, Peter. Thank you for giving us this really considered advice, and thank you for making the time to joining us from Victoria. And I'm looking forward to many more discussions like this in the future. Thank you.
Thanks so much, Hans, for capturing that wonderful interview with Professor Peter Doherty. It really put the issues confronting our sustainability agenda into compelling context. And, you know, we're particularly grateful to you for capturing that when we know that Peter Doherty is a man in such high demand at the moment. But it really set a tone of the importance of our recognition of the interconnectedness of our agendas around nature, culture and environment, and how our public policy and legislative frameworks really struggle to keep up with the change that we need to see happening as a result of our research. So thank you very much, Hans. So I'm now really delighted to welcome Ross Harding from Finding Infinity as our next speaker. So Ross is an engineer who has pioneered a unique approach to sustainability projects with a focus on self-sufficient architectural systems. He's worked on projects in Sydney, Melbourne, London, Stockholm, Mexico and Berlin. I had hoped to get to meet Ross in person in Canberra this evening, but we're nevertheless thrilled to hear him now present on the topic of the autonomous city, imagining how Canberra could become a world leader in a transition to self-sufficient architecture. So thank you, and over to you, Ross.
Thank you very much for having me. This next decade is a turning point in human history. We're all a part of it, and I'm really optimistic and excited about what is about to happen. Today, I'll share with you my perspective about what is about to happen and what is, in some ways, already underway. Our cities are both the problem and the opportunity. They're transforming from consumers to producers to become self-sufficient cities. It's inevitable. 100% renewably powered, water-neutral cities, zero-waste cities. An international undercurrent of cities around the globe is starting to move in this direction, a race to become the world's first self-sufficient city. This transition is not only inevitable, it's profitable. So to set some context, I will provide some brief background on the work we do in relation to self-sufficient architecture and master planning, and then come back to show you how, together with some of Melbourne's best architects, we're applying this to a city, Greater Melbourne. So as an organisation, Finding Infinity sits between research and application. So over the past 10 years, we've investigated hundreds of different buildings, looking into the costs of achieving net zero emissions, water neutrality, and zero waste. And we find time and time again that the outcome is actually profitable. This is from houses to city block master plans, all kinds of different projects. And so we look into a wide range of different initiatives, all kinds of things. We sometimes joke about it and say we don't discriminate against solutions. We're very objective in our analysis, and it's scientific analysis in a sort of pragmatic way. And then we bring finance to the table to understand how to actually apply that. So in some ways, we inform architectural developments with science and finance, basically, to try and really push the limits and accelerate the transition. And in effect, what we do is we find the most cost-effective pathway of achieving net zero emissions, water neutrality, and zero waste on projects. these initiatives can, in a sense, you can see here a range of different bits and pieces. I'm just flicking through a few examples so you can see the kind of work we do. But in effect, it's targeting the most sort of path of least resistance to achieve this on projects, and this is all totally accessible right now. The findings that we have has also been really astonishing in terms of where things are going. So we're starting to see initiatives such as zero cost living and zero cost operations in various projects is becoming more and more prevalent on projects. And typically in the private sector, it's often a barrier is cost. And what we're also seeing is that these projects are now able to be delivered on budget and having no negative environmental impact, which is a really exciting space to be in. So I guess we spend a lot of time chipping away at individual buildings and projects, but we did start to think what would happen if we applied this thinking on cities. And at this point in time, it's worth asking the question, why cities? What is it about cities that is interesting in relation to the global environmental situation? To me, it's kind of the Goldilocks situation. It's like there's a lot of discussion around sort of individual impact and then federal and national politics. But actually cities are, for me, the most interesting space to be playing in because it is the infrastructure that we need to change. It's the power systems, it's the water systems, it's the waste systems that are directly there. And politically, they're very connected with the citizens of those places. So it's a very interesting space. Plus 70% of the world's emissions is really related to cities. And about 2/3 of the world's population will be living in cities by 2030. So we basically just decided to take that same thinking and apply it to Melbourne, all 31 councils combined. And we spent about 2 years running the numbers on what it would cost to transition Greater Melbourne, all 5 million residents that are living there, to live in a city that was 100% renewable, water neutral, and zero waste. So we basically looked at, we started it by investigating what is happening in cities around the world. Not to come up with big new ideas, but we called it a new normal because we wanted to normalize the transition, not to pitch a radical future, but to investigate it in a really pragmatic way and just said, what would happen if we copy and pasted every single initiative that was happening around the world that was logical, cost effective and happening, tried and tested, and applied that in Melbourne today? How much would it cost and how much space would it require and what would the outcome be? So what we ended up doing was breaking it down into 10 different initiatives, from electrifying the entire transport system and architecture, introducing mandatory retrofits of all existing buildings, energy storage, solar on buildings, solar and wind grid scale, water treatment and reuse, waste to energy, ending landfill through regulation. And of those first 9 initiatives, they're all about transforming our existing cities, not talking about new projects. Finally, the last initiative that we identified that's happening is the introduction of new net zero building codes around the world. So we used all of this information to compile data and calculate what the energy transition would look like, moving from a city that's 80% based on brown coal to a renewable energy city, to a city that sends 84% of its wastewater to the ocean, to a city that has an unlimited supply of water, to a city that sends no waste to landfill. Then the approach was to understand the spatial requirements for each of these initiatives, and basically work out, does this even fit? We didn't know how much space it would require, and actually it makes a lot of sense as you start to look at the actual details. And we hadn't seen precedents of this before. We just treated the city like it was a building in a sense, even though the city is made up of 1 million buildings. So we worked out the costs. It came out to be approximately $100 billion. Each of the initiatives involved come out to have a payback period of around 10 years or less. So each of the initiatives required are profitable in their own right. And then the economic stimulus would actually create 81,000 jobs in construction and about 43,000 ongoing jobs from there. So in my opinion, it's really, there's a lot of discussion around why the environmental movement, and, you know, and also there's a lot of debate around a lot of arguments and discussions around what technology. And in my opinion, the rate of change that's required is so rapid that collectively we need to move into the how. And so this was basically where we moved into, was by inviting 15 of Melbourne's best architects over to my home in Fitzroy to work out how to actually, you know, move past the technical debate and actually start to understand how can we integrate the physical infrastructure that makes our city work with a cultural infrastructure that enables us all to thrive. And so these 15 architecture firms came together, and this is where this project became really exciting, is that it really transformed from a report and a strategy to something that's actually tangible and deliverable. So we've identified, from the work we've done, we've identified 15 projects to help unlock this $100 billion opportunity. So I'm going to quickly take you through the 15 projects and give you a very quick summary of the transition that is ahead. It's, you know, the time frame is brief, so there's a lot to discuss, but I'll just give you a quick overview. So in effect, we need to halve the number of cars in Melbourne by 2030, and then in effect electrify that half, basically. So getting the city off oil is not going to happen through basically, you know, everyone selling their car and buying new electric ones. There's a lot of work going on. An amazing company called Jaunt in Melbourne are electrifying existing cars currently, and this space is opening up more and more. And it makes a lot of sense. Electrifying the train system, interstate rail really needs to be brought up to scratch. And so in effect, this is a project about just upgrading the fit out in the existing train system to encourage train travel between cities, to create a viable alternative to flight between cities. This is, once we actually halve the number of cars and electrify, we've got 1.3 million electric cars distributed across the city. Collectively, those batteries add up to 300 times the largest battery in the world that was just installed in South Australia. So this is a significant portion of energy storage that can actually be used. It's called vehicle to grid technology, can be used for charging and discharging. So this is a project about activating our car park spaces to actually, you know, make them functional as well as technical. Then there's I think it's something like 600,000 you know, gas boilers in I can't remember off the top of my head, but in effect there's a gas is integrated into every single building in Melbourne currently. About the majority, 90% of all residents have gas in them. So this project is about creating a demonstration project to take an existing building off gas. And use it as a profitable example to demonstrate where we need to get to. So even if we have significant renewable energy supply, we still need to get our buildings off gas through mandatory retrofits. This next project is about introducing mandatory retrofits of all existing buildings. There's 1 million buildings in Melbourne currently, and it's a huge opportunity to actually retrofit across the board using profitable initiatives. Solar architecture, City of Melbourne currently is only tapped into about 1% of its total solar energy potential. And so by introducing solar energy on every second rooftop across the city, that creates about 38% of Melbourne's power currently. Solar and wind grid scale is also required to get there. And there's a great opportunity of dual use land, using wind and solar and combining it with agriculture and forestry. Water treatment and reuse. So basically, currently the backup plan for a lot of cities is desalination. but actually it's really expensive and not overly logical. So this is a project about encouraging the introduction of sewage water treatment, which is a much more cost-effective and viable alternative. All water is recycled, but there is public perception that's a challenge with it. This is a project about stormwater in our cities. About 10 times more water hits Melbourne every year than it consumes, but Melbourne's on track to run out of water by 2030. So we've got some work to do on stormwater. Waste to energy, you could fill Eureka Tower, Melbourne's tallest building, 9 times every year with how much food waste the city produces. So this is a project about introducing waste to energy in local pools, as local councils tend to take care of leisure and waste. And so this is profitable technology. It turns food waste into electricity it turns it into gas and creates electricity and heat as a result. And this is another project about waste to energy at the markets. Then introducing the circular economy in Melbourne is a great opportunity for the local economy, while also introducing the end of landfill. Then the last 2 projects is about a net zero building code. So and also net zero construction. So that's the quick summary of the 15 projects. The idea being that if we work with the private sector, actually we identified that 99% of the funds for this $100 billion transition will actually come from the private sector. So if we deliver these 15 projects together with the private sector to de-risk the transition for the public sector, this can help inform policy, and all while gaining support of the people along the way. So our objective is to bring together the public sector, the private sector, and people. Still, this is somewhat theoretical. And so this is where we really needed to move to the next step of how do we actually realize this project. And this is where things get quite exciting, is that we actually took the philosophy of saying they're renders, how is anyone going to actually connect with the project? How are we going to get the funds to deliver the projects? People think that I'm probably a little bit insane. So let's basically create small-scale examples of these projects through prototyping. From temporary, we can create permanence. So we basically got some funding from City of Melbourne, took over a rooftop in the city, and we built all 15 prototypes of all of the projects in physical form. So I'll quickly fly through some of these pictures to show you what that looks like. This is the battery bank. This is the induction cooktop. This is the rooftop solar system. This is the rooftop solar system. This is an artist, Ash Keating, with the solar system. His amazing work. This is Nick Harding with his solar greenhouse. And then this is Mark Jakes with a water treatment plant. And this is Mon and 6 degrees, and this is Rachel Nolan. So that was just a snapshot of the various projects, but that allowed us to gain a lot of traction in terms of press, and particularly the Fin Review helped us pitch for 50 mil in investors to help progress the project. So then this is our trajectory of investment timeline. So the goal is to seek 50 mil this year to build the first 15 projects, then 500 mil, then 1 billion, 10 billion, and then it's 18 billion every year from there. Now, this might sound radical and a lot of money, but actually this is what is required at that scale to actually achieve this transition. And that money is profitable. It's not just a handout from the government that we're seeking here. This is just about directing funds in the right direction to create a self-sufficient city. So what's really exciting as an outcome is that we've already got four of the projects funded. We've still got 6 months to go. And we just launched in May, or no, it was in March actually. And so we've got 2 that are very close now, and we're still seeking funds for the other 9. So this is also something that is really, actually popping up, is that Jens Blaze tuning in at the moment from Hamburg. He's also sought EU funding for a new normal radar in Hamburg. So the project is starting to move in Hamburg. We're in conversations with City of Adelaide, Auckland, Wellington, and trying to actually help create this competition between cities as to who will get there first. So in summary, it's my position that I think it's time for us to move past the why and focus on the how. Let's plan together. Let's stop blaming the government. Let's stop blaming business and the people ourselves. We're all behind. Let's focus on optimism and plan ahead, and let's dream a little and make that dream a reality for the next generation and every generation after that. We can leave the next generation with cities that are based on unlimited resources and leave them with unlimited potential. Thank you.
Okay. Thanks so much, Ross. I really enjoyed your presentation there. And we found it particularly exciting because of the way you set out this radical and exciting vision, but made it, very much tethered to the contemporary and made it look achievable and economically feasible. And something that's come up again and again in our previous symposia on sustainability and heritage has been the importance of the private sector in achieving this vision. Heritage as a sector in particular has been so strongly tethered to government funding in the past, and we know that is changing. And that private sector in many ways are leading the way through their actions. I also loved how you talked about the paths of least resistance as showing, opportunities to be sought out immediately, and the importance of citizen action, I think, also really resonated with our project and our previous symposia on this theme. So thank you, Ross, and audience, please make sure that you send through your questions to Ross so that we can come back to him in the round table. So from the macro focus of the city, we're going to zoom in again now and zoom back to a focus on the Shine Dome itself and the Sustainable Shine Dome project. And so next we're joined by our co-investigator from GML Heritage, Catherine Forbes, who's joining us sadly remotely from lockdown in Sydney. Sorry, Catherine. But Catherine is an architect and an expert in heritage conservation and sustainability. And she's an expert member of the ICOMOS International Scientific Committee on Energy, Sustainability and Climate Change, and has played such a crucial role in this project. So over to you next, Catherine.
Thank you very much, Tracey. I get the pleasure of introducing everybody to the Shine Dome and to the Sustainable Shine Dome project, which is really one of those prototype projects that Ross has just been referring to. And we're looking at sustaining a national icon, a place that is on the National Heritage List. So I'm going to, because I know that a lot of you are, well, you're all online, but not many of you may not actually know the Shine Dome. I'm going to take you on a tour of the Shine Dome and introduce you to its national and Commonwealth heritage values. I'm then going to talk about the goals of the project and how that links to sustainable development goals and to environmental, social, cultural and economic sustainability criteria. And then I will look at some of the key elements of the Shine Dome and talk about some of the heritage issues and sustainability issues that we're trying to address and the opportunities for doing that and for improving the sustainability of the Shine Dome, including energy efficiency. So we were just standing in the entrance foyer of the Shine Dome, and now we are in the main theatre, which is at the heart of the building. So the Shine Dome, as I said, is on the National Heritage List, and one of its primary heritage values is its connection with the Australian Academy of Science, which was established after or during the 1950s and has a similar charter to the Royal Society from which it has come. And it was established to promote Australian scientific research to Australia, but also to the world, and promote the debate around that research as well. So this is the theatre. The theatre is located right at the centre of the building. And the building was built as, it was the winner of a design competition, and it was won by Grounds, Romberg and Boyd in 1956. And Roy Grounds, the principal architect for the building, is one of Australia's best known mid-20th century architects. And here you can see the plan of the building. It's the sections through the building showing how the plan translates into the three-dimensional form and what the building looked like in the Canberra landscape of 1959. It is a truly unique building. So the building was designed for its place. So it responds to the local Canberra landscape, as we saw, surrounded by hills, but it also responds to the urban landscape of the new city that was to be built around it. Canberra has a lot of geometry in its layout and curvilinear sites, and so the Shine Dome sits on one of those in a key location near the Australian National University, which was just being established at the same time. It is a rare example of pure geometric structuralism. As I said, the geometry of the plan extends into the three-dimensional form. It extends from the exterior to the interior, and it's clearly expressed in every aspect of the building. So you can see the vaulted ceiling over this main function room radiating out from the central dome that was around, drum around this core of the building, which is the lecture theatre. It is Australia's largest freestanding concrete dome, and it is a very unique structure. The moat is integral to that structure. It holds the dome in tension and holds it together, so they're designed and built together. The curtain wall that you can see through under there is not load-bearing and is not actually connected to the dome. It does not support the dome. So this is from the inside. You can see that the design is fully integrated from exterior to interior, from setting to the furnishings. All of the furnishings were designed with the building. The finishes all extend from the interior to the exterior, and you can see how it integrates with its surrounding landscape, and the light that comes into the building that bounces off the moat and up onto the ceilings of the building. So here we are in the lecture theatre. You can see the original seats are still here, the desks that the fellows sit in for their meetings. These were all part of the original design. The interiors feature all natural materials and finishes. So we've got face brick walls and clear finished timber battened walls. We've got wood and linen used in the furnishings, copper on the roof, vermiculite, which is a mineral, is used on the ceilings, and we've got terrazzo floors and benches, and they go from the interior to the exterior of the building. It is a place of innovation. It has always promoted innovation from its original design and structural system through to the treatment of the walls of the theatre. So originally, the walls have acoustic properties, but originally they created an optical illusion which had to be resolved, and very early on this was done by colouring some of the timber battens and introducing wound jute strings between the battens, which stopped causing that illusion and the headaches that resulted. It is also a place that holds knowledge, scientific knowledge and research. So this is the Adolf Basser Library, and we have the Fenner Archives, which is a collection of scientific material which is of national significance. So, as I said at the beginning, this is a pilot project or a prototype, and it presents an innovative approach to the management of places on Australia's National Heritage List, enabling those places to be conserved, but in a way that addresses global issues of sustainability and climate change. So the project goals are to conserve the national cultural heritage values of the place, but to maintain the connection between the academy and the place and ensure that the academy can keep using the place. To conserve the significant form, function, structure, spaces, finishes and setting, but to apply a spirit of innovation to any adaptation or improvement that needs to happen for the future of the place. So we will apply sustainability principles to all work undertaken. So the Shine Dome has a heritage management plan, which is the key document that talks in detail about the heritage values of the place and how to conserve them or what needs to happen to conserve them. But we're producing a sustainability plan which will supplement the heritage management plan, and it will demonstrate how to conserve the cultural values but to enable sustainability issues to be addressed, including improving energy efficiency through sensitive adaptation. So I'm going to look at this UN Sustainable Development Goals. Goal number 11 is about sustainable cities and communities. And that goal is to make cities inclusive, safe, resilient and sustainable. But within that goal, there is a target to strengthen efforts to protect and safeguard the world's natural and cultural heritage. So when we look at those two together, what does that mean for the Shine Dome? So to be inclusive means that the place is accessible to everybody, regardless of age, race, gender or ability. It is a safe place to be. It's free of hazardous materials. It's safe in a fire, any of those things. It's resilient. It is long-lasting and durable and will survive and thrive through disaster. And we've had several of those, as already spoken about. And to be sustainable. So we're looking at environmental, cultural, social and economic sustainability for this project. So cultural sustainability, what is that? Well, it's about conserving the national heritage values of the place. It's about adopting Borough Charter principles, which is our key guidance document for cultural values in Australia. And many of the principles in that document are very closely aligned with achieving environmentally sustainable outcomes. So repair rather than replace, actions should be reversible, and that we only do what is necessary. And then to follow the heritage management plan policies. Environmental sustainability includes looking at energy efficiency, the thermal performance of the building, accounting for the embodied carbon within any products or materials used, to minimise material consumption and waste, and to minimise water use. Social sustainability is maintaining the Dome as the principal meeting place of the Academy, facilitating that knowledge sharing that the Academy is very much a part of the Academy's activities, so education and research, ensuring that the place is safe and accessible and provides a healthy environment, and economic sustainability. So the sustainability plan to reduce operating costs will also reduce costs for the building and the functioning of the building. But we're also looking at improving flexibility and functionality of the spaces, increasing and improving access to these types of events. And we have an online event tonight. We've been doing hybrid events, maintaining the place in good condition, ensuring its durability and longevity. So I'm just going to look at a few key elements. I'm going to look at the building envelope, because usually when we talk about thermal performance, we're talking about the performance of the building envelope in maintaining a comfortable environment inside the building. We're going to look at the setting of the building, and we're going to look at a couple of the interior spaces and the functionality of those. So we'll start with the roof, which is the dome, the copper-clad concrete dome. The copper protects the shell. Originally it had vermiculite insulation and fire protection. It still has that. The dome shades the windows to keep out the summer heat. But in early 2020, we had a huge hailstorm, and that copper cladding that was on the dome reached the end of its life. It was no longer functional, and we had major leaks coming into the building, which affected not only the building, but the interiors and the library collection. And so as an insurance claim, the roof has just been replaced, or more accurately, the old roof is still there and a new roof has been put over the top of it. So it's really important to conserve the dome in its original form because it's such a significant structure and it's such an important part of the value of the place itself. But to improve its resilience through the introduction of new waterproof membranes. We looked at the recycling of the copper. That was not possible because of the way it was fixed to the originally, and we couldn't remove it without damage. But the new roof is totally reversible. It can be disassembled. It will be able to be recycled at the end of its life. With regard to thermal performance, this all happened before our project started, but we did discuss it through the project, and so there is now an air gap between the new and the old roofs, and so the roof can now be ventilated so it doesn't get quite so hot in the summer. Unfortunately for this particular building, we can't really put solar panels on the roof, but fortunately Canberra does have a renewable energy source for all its electrical supply. So the next feature we're going to look at is the curtain wall. So it's a very significant part of the building again. It's aluminium framing, it's single glazing, and there is a gap between the top of the curtain wall and the underside of the dome. And that was necessary because the dome needs to be able to expand and contract with the diurnal temperature ranges, which in Canberra can be quite extreme. It can be very hot and it can get to quite very cold. So the aesthetic qualities of that glazing is, the rhythm of the framing is a very important part of the building. It provides this incredible visual connection between the interior and the exterior, and it allows the very important light that comes off the moat and reflects on the ceiling, and it shimmers within the building. It's a building that's full of light. So we have issues with thermal performance for the glazing. The frame is highly conductive of heat. The glass allows the heat to transfer through very easily, and the gaps also allow that heat transfer. So we've been looking at options for how to resolve that. We do need to retain the original frames. They're very much part of the significant fabric of the place, but can we fill the gaps and provide some sort of seal to reduce that infiltration? Can we upgrade the glass? And can we provide secondary glazing as an alternative? The moat is incredibly important. As we've spoken before, it's integral to the structure of the dome. It links the dome to its landscape setting. It connects the interior and the exterior, and it reflects that light into the interior of the building. What I would really like to know more about is its capacity to moderate the climate around the building. In arid countries, traditionally, you would use water and gardens to cool the air in those very arid climates, those hot climates, before it enters the building. I suspect the moat does that. It also has the capacity to store heat during the day and re-emit that in the early evening to make it a little bit more pleasant on winter evenings. options that we've looked at is whether the water in the moat can be used for other things, because this is the roof water that you would normally collect and store in a rainwater tank. Effectively, the moat is our rainwater tank. The water is filtered, but it's not potable water, it's not drinkable, but we can use it for the watering the landscape perhaps. The landscape provides the setting for the dome, and we need to maintain that open setting. But the landscape also reduces summer temperatures. Drought-resistant plants should be used, perhaps, and it may be possible to introduce some shade trees over the hard paved areas, provided it doesn't obscure views of the dome. This is the Ian Walk Theatre. It is the heart of the dome, and as you can see, everything about it is original, from the light fittings to the furnishings to the blackboards behind the desk on the podium. There are issues with the angle of the seats. There's issues with access into the theatre for wheelchairs. The podium's not particularly flexible and not particularly suited to modern presentations. So we've looked at ways of upgrading all those things to make it more, to enable the theatre to be ongoing in its function as the main meeting space for the Academy. And the library and archive, such important components of this place. Most of the records are paper-based. They're vulnerable to dust, fire, flood, humidity, mould, theft. They're not digitally accessible, they're not physically accessible. The library's on the upper floor, the archive is stored in the basement, and therefore someone in a wheelchair cannot access them. This is resolved at the moment by the librarians providing those materials to people at ground floor level. But at the moment, we're digitising the collection and providing online access. So just to conclude, the question is, what's next? So I think we need to better understand the performance of the roof. We better understand the opportunities for the moat. We better understand the energy savings that can be gained through proposed upgrades to the building, and GHD is going to talk about that in a minute. And we need to take a life cycle assessment of any proposed upgrades. So we're measuring the energy used in doing the upgrade against the energy embodied in the materials that would be lost through that upgrade. And at all times, ensure cultural heritage values are conserved and maintained. So thank you very much.
Thanks so much, Catherine. And because we're running late, I'm going to switch very quickly over to Ngui, who's also joining us here in the Shine Dome this evening. May's from GHD, our partner on the project, and she's a regional general manager and a trailblazer for women in engineering, the first woman appointed to the board of GHD in 2009. We're delighted that May will be sharing outcomes from GHD's modelling and testing of several building design initiatives. Thanks so much, May.
Thank you very much, Tracey, and I'm delighted to be able to be here presenting to you from Canberra. And good evening to you all. First of all, I'd like to acknowledge the traditional owners of the land on which I'm standing, the Ngunnawal peoples, and pay my respects to the elders past, present, and future. So Catherine's taken us on a very interesting tour of the dome through heritage architectural eyes. And now I'm going to walk you through the engineering considerations for reducing energy consumption at the dome, which unfortunately means I'm going to show you quite a lot of numbers and figures, as opposed to Catherine's very beautiful and evocative photos of the dome. So we were engaged to review the current energy consumption of the dome and to investigate innovative initiatives to reduce the energy consumption. And our initiatives relate to improving passive performance of the building through upgrades to the building envelope, and applying active measures targeting system settings and equipment energy efficiency. So we were looking at up to 8 initiatives to improve energy efficiency. So I'm going to take you now through a very quick overview of what we did to do our modelling. We accounted for 4 scenarios. Baseline 1, which involves the use of the existing boiler. Baseline 2, which considers replacing the boiler with an electric heat pump. And then individual strategies with each initiative proposed being compared to baseline 2, which is based on the use of electric heat pump. And then we look at a combination of strategies, which, when applied to the building, will have improvements to the energy efficiency compared to baseline 2. So the model was developed using a software platform called Integrated Environmental Solutions. It's a virtual environment. We actually created, using this software, a digital model which gives a very detailed representation of the building, and including its geometry, its thermal properties, and building services, and the building interaction with internal and external climatic conditions. So what was our assumption? What were our assumptions for baseline 1 and 2? So prior to undertaking the actual options assessment of potential energy savings from using the different initiatives, we needed to develop a reliable baseline model, which we did through ongoing calibration using the current conditions of the building and basing that on available historical data. So the methodology for undertaking base case 1 involved us looking at historical electricity and gas bills dating back to 2018. We then undertook several site visits and reviewed the existing information on the equipment, such as the air handling unit profiles, as a basis to form the calibration of this model. And then we went on to refine the assumptions based on occupancy profiles, equipment loads, hot water systems, and the building fabrics, which resulted in the final base case model iteration, achieving a variance of less than 5%. So when we completed calibrating base case 1, we then developed base case 2, reviewing the as-built and as-constructed documentation of the systems and the specification of the HVAC, the heating, ventilation, and air conditioning system specification provided by the mechanical contractor who was engaged for the heat pump installation. So if we look at the energy usage, the energy consumption graphs, you could see that there's the electric heat pump option really yielded a lot more savings there, just for comparison. So what we did then was to start modeling the different initiatives. So I'm going to quickly take you through the initiatives now. So initiative 1A involved the infiltration considerations. Air infiltration refers to air leakage through unsealed joints in a structure and around the windows. So a leaky building allows unwanted cold air to sit indoors during the winter and warm air in during the summer. So the air exchange rate, also known as air changes per hour, or ACH, we then use this parameter to assess the infiltration or air leakage through the building per hour. And we use 2 parameters, as you can see. So I won't talk through all the engineering calculations and parameters, but what you can see is that the overall energy saving for considering air infiltration is about between 5.5% to 7.6%. And the second initiative was around the infiltration on level 1 around the duct space and the Bachor library. And you can see that it yielded, the calculations yielded a smaller savings of between 2.6 to 2.9%. The third initiative involved us looking at glazing, which involves really only the replacement of the existing glass. The glazing system is an important component for us to consider in an engineering exercise like this as part of the heating and cooling of a building. And glazing with a total system performance of a lower U value, and the U value is a measurement of heat loss, generally translates to high ability in retaining heat. And so we did take into consideration the heritage constraints where the original window frames are to remain. And so this option really assessed only the replacement of existing glass. The next slide shows an additional glazing to be applied. And we considered this option to improve the total glazing performance through adding a glazing system behind the existing glazing systems. And this allows us to compare the overall energy savings to the replacement of a glass-only option. And you can see that, again, it's the energy saving is not that much. It's between 1.5 to 1.6%. So the fourth initiative involved us looking at the domestic hot water system. It's currently supplied by 2 electric resistant boilers. And this initiative investigated the potential savings from the replacement of these existing boilers with electric hot water heat pumps. And that used a savings of 15.4%, as you can see on the screen. Our fifth initiative was to consider added internal insulation, which, as you can see, really wasn't that much of a saving. But I will note that wall insulation acts as a barrier of heat transfer between spaces. And it was identified during our walkthrough of the domes that we saw that the dome's internal wall linings separating the duct space to the conditioned areas do not currently have any insulation. So adding insulation bats to the existing stud walls will reduce the path of least resistance for heat transfer and help resist unwanted heat loss or gains. The sixth initiative of the 8 that we looked at, we looked at the efficiency of the fan motors. And this is getting very engineering here, so I apologize. But the current best case model assumes a fan motor efficiency of 80%. And this initiative we looked at takes on a theoretical approach where a 5% improvement target will give us some improvement. And that's a 2.5% overall energy efficiency, with 85% motor efficiency generally available for most high efficiency motors. So the 7th initiative, we considered lighting upgrades, involve modeling the building with the addition of lighting controls to provide more responsive lighting conditions for the building. And the intention of this modeling exercise was to determine how much more energy efficient the building would be by implementing controls which limited the time in which lights were switched on during the day. And by providing these controls, The model measured the energy savings that would be generated from having responsive lighting, as opposed to lights being turned on continuously throughout the day. And you can see that it varied, the savings varied between 3.6 to 4.8%. Then we looked at combining the strategies, and that really gave us a big jump in the overall energy saving of 26%. And the combined strategy model assumed the following conditions: that there will be a curtain wall, an upgrade to a heat pump, the glazing upgrade, a lighting upgrade, and internal wall insulation. So combining some of the previous strategies that I spoke about. So I'll show you now the comparison of the initiatives, and you can see that the combined strategies, where the green coloured cells are on the Excel spreadsheet that I'm showing you here, is actually yielding the best savings for us in energy. So if you look at just going through the slide in front of you, the glazing value really doesn't you too much. But if we combine a few of those strategies, we could actually get between we can get a percentage saving of about 26%, and yielding a energy savings of about 59 cents. I'm trying to look at my screen here with a very, very small print. It's got the highest cost savings for the combined strategies. So our implementation plan still needs to be considered in collaboration with Catherine's team at GML Heritage and the University of Canberra. And it will be the following steps. And that's why I had the caveat that we're just presenting the findings to date, and that we still need to come together to consider a multi-criteria analysis and to really take into account what are the best combination of the initiatives that we've put forward. So our summary findings are about looking at the domestic hot water system, reducing infiltration, and the glazing, as I said, really introduces a little bit of savings, but we still need to consider that as part of the multi-criteria analysis. And when each initiative is assessed and compared against the best case, we feel that the improvement may not seem significant, but a combination of these strategies demonstrated that energy savings can be reduced by at least a further 26%. So thank you, Tracey.
Thank you so much, May. So now, because we're running slightly over time, I'm going to have a short roundtable discussion, and I'm going to be joined by all of our speakers, along with our colleague Ty Hollingsby from GHD. We've had a great array of questions sent in from members of the audience, and we don't have time to ask them all. So I've chosen just a couple, and I'll ask panel members to keep their responses quite sharp before I throw to Professor John Shine to sum us up with his reflections on this evening. So the first question that I've chosen, Ross, goes to you, and it comes from Julie in our audience, and she's asking you, can you speak a little bit about the role of historic built fabric and cultural heritage, and cultural engagement with place and creative interactions with place within your vision for the transforming city?
Yeah, I guess the way that we're looking at it is under the topic of basically energy efficiency retrofit is one side of it, which is basically that I think that in the past there's been certain environmental programs that are sort of blanketed across all technology, saying, you know, we need to put insulation in everything and we need to do this and everything. And our approach on that is to say every building needs an audit, and you know, simple audit, and what is most cost effective should be applied. So sort of objectively looking at each building for its own merits. And I think particularly, yeah, I mean, I guess there's a huge topic around embodied energy and embodied emissions. And I think the idea that we are constantly talking about this topic in terms of new buildings, knocking down old buildings to build new ones, doesn't really make much sense in that sense. So I might end there to keep it quick, but I can keep talking if you want.
That's fabulous. Thanks so much for your quick response, Ross, to that really big topic. But that segues really nicely into my next question, which I'm going to throw to Ty and May, which is, you know, can you tell us about, you know, emerging technologies for measuring and validating embodied carbon? You know, do we have the tools that we need? Is it just a question of embedding them in you know, decision-making processes, or is innovation required in that area?
So, May, I'll probably answer this first off. You know, the industry and the research around embodied carbon in the construction space is very well advanced, and there are substantial and very impressive sort of packages and software and databases that have been established, both across an international sort of context of data sets, but also specifically for the Australasian context as well. And so that is readily available to, you know, businesses and entities like us, and all sort of and anyone in the marketplace actually, both at a commercial level and also sort of in a free model. You know, I would probably point to the University of Melbourne as a really good example of some of the work that they have done there over the last 10 to 15 years around embodied carbon in the context of the Australian construction industry. Work that are like that and packages that are available for designers and engineers like us make decision-making substantially easier, but also relevant to the Australian context, which I think is an important thing to consider here, because international data sets don't necessarily relate or indeed help us make the right decision about what we might want to do on the Shine Dome, for example. Whereas the material database and materials that are available in the Australian context helps us make that right decision. So I would say there's always room for innovation, of course, but I would probably back our industry and back our people that it's actually very well advanced.
Fantastic. Thanks, Ty. Do you want to add to that, May?
No, I was just going to say that I would heartily concur with that, Tracey.
Fantastic. Okay, well, I think in the light of those two questions, I want to throw a question to Catherine, and that is, should we still be talking about old-fashioned heritage management plans, Catherine, or should all National Heritage listed places have sustainability plans, you know, essentially?
I think the sustainability plan is certainly a very positive addition. I actually think heritage management plans need to include policies that respond to these issues, to respond to the need to be more efficient, respond to the need to be less wasteful. And heritage offers so many positives in that aspect. And if we acknowledge them in the heritage management plan, that's a really good starting place, because there'll be policies in those documents for the management in relation to that place. The sustainability plan goes into a lot more detail, and I think that's actually a really, really useful document. And I'd love to see it for all Australia's national heritage places. I'd like to see it even at state level. But let's start with the Shine Dome. I think it's a really good starting place. It's a great example.
Fantastic. Thanks, Catherine. That was a great answer to end our very brief roundtable. I'm sorry, everybody, about the brevity of that. I can't do my normal chair thing of monstering over the speakers when I'm sitting up here in the heights. But now I'm going to throw to Professor John Shine, the President of the Academy, and ask for your reflections on this evening.
Okay, thank you. A few technical issues apparently. Thanks very much, Tracey. Look, I'll be very brief, just a couple of comments. Look, I mean, we all know the Shine Dome was originally envisaged as the sort of prime location for national science meetings in the nation's capital. And while that remains true today, we've moved with the times quite a lot to where we now not only hold important national and international scientific meetings, we also workshop the role of science in addressing the major global challenges facing the world. And importantly, in today's environment, these are broadcast live, as we've seen tonight, or in various curated formats to a wide range of external audiences. We can reach well beyond those who might regularly engage with us to ensure that genuine scientific knowledge is available and understood by the wider community. In this age of social media, with a lot of the misinformation that goes with it at times, it's critical that we're seen as a trusted source of such knowledge to help guide best practice in policy development for our future economic and social benefit. And it's really in this context that the striking architecture of the dome, which has become an iconic image of Australian science, helps us get attention to the importance of science. And the exciting program that we're talking about tonight to update the dome to be at the cutting edge of sustainability for the future plays an important role in helping us to get this message out there. We need to take much better care of our planet, it's a very finite piece of rock, so future generations can enjoy the quality of life that we're used to. There are many challenges, especially in the face of our exploding population and the resources that requires. Challenges to which any real solution requires application and innovation, but innovation based on knowledge provided by science. And the Sustainable Dome shows that Australia's scientists will lead by example. And certainly I think that's what the project's all about, showing that as scientists we believe this is so important and we will lead by example with our own building. So thank you very much to the project team. They're all listed earlier, I think, Tracey, by yourself, and the speakers here tonight, fantastic. I mean, it's not my area of expertise, but I've been fascinated by the talk. So I really appreciate all the effort that the team and the speakers have put in. And so thank you very much from all the fellows of the Academy. Back to you, Tracey.
Thank you so much, John, for those forward-looking reflections and a wonderful mantra there of the Academy leading by example really rings true for our project. So we've come to the end of our events, so I will thank again our remote audience for joining us, and a huge thank you to all of our speakers for their intelligence, their passion and their energy around these topics, which has certainly piqued my interest to explore many of your areas further. Thanks to our partners at the Australian Academy of Science for hosting this wonderful event, and to my colleagues at the University of Canberra, GML Heritage and GHD. So please continue to tweet at the Sustainable Dome, and keep in mind that this evening's symposium, along with the first two symposia, are available to watch and share as recordings on YouTube on the Academy's website. A great teaching resource for many of us, I think, as well. So just type in Academy of Science Sustainable Shine Dome and you'll find the links. So good night to everybody. Stay safe and stay connected. And thank you once again for a wonderful symposium.